Hello, pre-calc fans. This video brought to you by Lego Space Police. That's what SP stands for here. But this is Space Police 1, not 2. Now, if you're true diehards, I believe this should be a green, neon green visor. At any rate, we're going to look at a couple more identities in 7.2, and these are the cofunction, the double, and the half-angle identities, those three. So let's do a quick review. Remember, they are cofunctions of each other, meaning they're more or less translations. Like if you look at cosine, at 0 cosine starts at 1, but if we were to do a shift of this many units, a horizontal shift of that many units, we would end up with sine right here. Okay, so this, if we look at what this distance is, this is a distance of pi units. So if you recall that stuff we did way back in chapter 2, that f of x, or a times f of x minus h plus k, all that mess, we're thinking about this being an h value. So it feels like if we did something like cosine of x minus pi halves, we should end up with a shift of this many units to the right, and then we're going to get the exact same shape as sine x. We could do a similar kind of reasoning with cosine, starting with sine, noting it starts at 0, shift it pi half units to the right, we get that. But we can also shift it to the left. That's the wonderful thing about these trig functions. They're circular, right? So they repeat over and over and over. In fact, every 2 pi, we get a repeat. All right, so here's the identities. Note they're kind of written in a slightly different form. So if we do sine of pi halves minus x, we get cosine x. If we do cosine of pi halves minus x, we get sine x. So these are the cofunctions, and they're always true. Okay, we're going to actually prove one of these using a previous identity. And that previous identity is the one from the last section, the sum identity. That is this one, sine of u plus v equals blah, 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 blah. All right, so I'll write it down. I'll write the identity up here. Sine of u plus v equals sine u cosine v plus sine v cosine u. So we're going to do that for this thing and just see what falls out. In other words, that is going to equal sine of x times cosine of pi halves plus, let's see, sine of pi halves times cosine of x. Now, we got to jump to the unit circle and see what happens, what are the values at pi halves. So note this is pi halves, and that point here happens to be 0, 1. So I guess I should put this in, right? So cosine of pi halves happens to be 0, and sine of pi halves happens to be 1. So if I plug in this other part from this identity, note what happens. This becomes 0, gone, and we're left with just 1 times cosine, or cosine x. So we're saying that sine of x plus pi halves is equal to cosine x. Ooh, isn't that wonderful? That's very similar to our cofunction identity that we just wrote down back here, right? Oh, that's the wrong one. Where did I put it? Over here. So here we had sine of pi halves minus x equals cosine, and now we're showing that sine of x plus pi halves is also equal to cosine. Wild. All right, let's do another one. So we're using a previous identity. What we're meaning is a sum identity. I will write that right here. If we have cosine of u plus v, that's equal to cosine u times cosine v. And in this case, since we're adding, our identity says we do subtraction. Oops, it's not cosine. Shame on me. It's sine u cosine of v. All right. So we're going to rewrite this, because it's in this form, in this form. Here goes. Cosine x times cosine of pi halves minus sine x. Now, I just recognize I'm randomly putting in parentheses for our thing. Don't ask me what my brain's thinking. It's weird. Oh, this should not be cosine. This should still be sine. Sine of pi halves. Okay. So, as before, this is 0. So all this is gone. Minus sine x, sine of pi halves just as above is 1 times sine x. So our result here is just negative sine x. Now that is not the same as the previous identity. When we subtracted, when we had cosine of pi halves minus x, we got positive sine x. Now we're getting negative sine x. All right, for this one, we're being told to use these previous two identities. So this one and this one to rewrite tangent. There is a reason we're not saying use the sum or difference identity. In other words, use one of these identities to do it. And that's because tangent of pi halves is undefined. So we cannot use that identity. However, we do know that tangent of x is equal to sine x over cosine x. So we could rewrite this thing. We could say that tangent of x plus pi halves is really equal to sine of x plus pi halves over cosine of x plus pi halves. Now here's a very common strategy in the math world. Use previous results to help with these results. So we already showed what this was equal to right here. So this becomes cosine x in the numerator. And we already showed what cosine of x plus pi halves is equal to. It's right here, negative sine x. And then we just need to simplify this mess. Well, this becomes, note that negative. Negative, what's cosine over sine? That's cotangent. So this thing is equal to negative cotangent of x. That's a new identity. All right, we're going to use the same idea to do the rest of these. All we have to do is recognize kind of an intermediate identity, a basic identity, and that is that this is really 1 over cosine of x plus pi halves. And so we'll take our result of what cosine of x plus pi halves was equal to. It was negative sine. So this becomes 1 over negative sine x. Well, and we know what 1 over negative sine x is. That's just cosecant. So this is negative cosecant x. All right, this one is 1 over sine of x plus pi halves. From above, we knew that sine of x plus pi halves was really 1 over cosine. Why am I writing plus pi halves? Get rid of that. Sine of x plus pi halves was just 1 over cosine. And then we know that 1 over cosine is really just secant x. And finally, cotangent is really cosine over sine. Boy, I don't want to write this, but I'm going to do it anyways. Cosine of pi halves all over sine of x plus pi halves. And so we knew that cosine was equal to negative sine of x, and sine was equal to positive cosine x. So cotangent of x plus pi halves is equal to negative tangent x. And there we have a whole new set of identities. This is equal to this is equal to this, and finally that equal to that.